Hi everyone, in this section we're going to review a bit about Pythagoras Theorem and sine, cosine and tangent rules. Okay, if we look at this picture here, this will help us prove the formula for Pythagoras, which you should already know, which is a squared plus b squared equals c squared. Imagine we have a right angle triangle here and we have two sides, a and b, and the length of this side is 4. Okay, and so the area, which is 4 times 4, is 16. On this side the length is 3 and the area of B is 3 squared, which is 9, and the hypotenuse, which is the longest side, is 5 times 5, which is 25. And if we add those values, a squared plus b squared, 16 plus 9, we'll get 25. Okay, so that's one simple proof for the Pythagoras theorem, and that will work on every question. Okay, in the example we want to find the length of the hypotenuse, which is x, and the hypotenuse is always opposite the right angle. So this is a hypotenuse here. Okay, that's always the hypotenuse, and all we need to do is put the values into the formula. So we have 7 squared, which is a squared plus b squared, which is equal to x squared. Okay, that's the hypotenuse. 7, 7, 49, 11 squared, 121 equals x squared. And 49 plus 121, that's going to be 170 equals x squared. And so the x will be the square root of 170, which is 13.04. And the unit there is centimeters, cm. Okay, in this question the hypotenuse is already known, which is 12, but we need to find the other side. So we use the same formula, x squared plus 8 squared equals 12 squared, which is 144, and 8 squared is 64, so we write that. Okay, so x squared will be equal to 80. So x will be the square root of 80, which is 8.94, and the unit cm. Okay. In example 2 here, we want to know if this triangle here is a right angle triangle or not. And Pythagoras' theorem only works for right angle triangles, so we need to check this angle here. So when we do this kind of question, the longest side is always considered to be the hypotenuse. So this could be called A, this side could be called B, this side could be called C. And we need to check these values satisfy Pythagoras' theorem. So we would have 10 squared plus 24 squared. We want to know if that equals 26 squared, yes or no. Okay, so 10 squared is 100. 24 squared is 576. And 26 squared is 676. So we need to see if these two sides are equal. So if you add that, you can see you're going to get 676 equals 676. Okay, so that's true. That means that this angle here is a right angle. If these are not equal, this is not a right angle. Okay, this is example 3, and we'll use Pythagoras' theorem here as well. A guy rope is attached to the top of a tent pole at a height of 1.5 meters above the ground and to a tent peg 2 meters from the base of the pole. How long is the guy rope? Okay, so the rope here, this is the rope, the peg is in the ground down here, and the pole here is there, and that's 1.5 meters long. This length here from the peg to the base of the pole is 2 meters. We need to find the length of this, and looking at that, we can assume that the pole is at a right angle to the base or to the ground, so we'll put a right angle there, and we'll use Pythagoras Theorem to find the length of the guy rope. So we could have our a squared plus b squared equals c squared. So a can be 2 or 1.5, it doesn't matter. So let's use 2 squared plus b, which is 1.5 squared, equals c squared, and we don't know the length of the rope. Okay, so 2 squared is 4 plus 1.5 squared is 2.25 equals c squared. Okay, so we're going to have 6.25 equals c squared, and c will be the square root of 6.25. So c will be 2.5 meters. Okay, don't forget the unit because we are given units. Okay, in example 4, this is a little bit more tricky. Paul walks 3 kilometers east and then 10 kilometers north. He then walks east until he is 20 kilometers from his starting point. How much further east has he walked? Okay, so I think the best way to start here is with a graph. So let's start at the point here. So here we have north, this way is east, this is south, and this is west. Okay, so we're going to go 3 kilometers east. So I'm going to go in this direction 3 kilometers. Alright, km. And then 10 kilometers north. So I'm going to go up here somewhere about 10 kilometers. Alright, and then he walks east until he is 20 kilometers from his starting point. So he's going to go this direction to the east until he is 20 kilometers from the start. So let's change the pen there, the color. So from here to here is going to be 20. So that red line is 20. Okay, so I'm going to draw a dash down here. Okay, so we have a triangle here. Okay, so he's gone 3 kilometers and then 10 kilometers up. So if this is 10 kilometers, this line is also 10 kilometers. So I'm going to write 10 here. What you need to find is this length here. It says how much further east has he walked. So this is how much further he walked from this point. So this is the length we need to find, and we don't know that. So I'm going to call that x. Okay, so here we have 20 kilometers. This is 20, this is 10, and this is what? 3 plus x. So we need to find this length x, and you can see here we actually have the Pythagoras form, but we're going to end up with a quadratic. So let's consider this to be the length a, this is b, and this length 20 is going to be c. Okay, so let's go back to the black pen. Okay, so we're going to have a squared plus b squared equals c squared. Okay, a is 3 plus x all squared plus b, which is 10 squared, equals c squared, which is the length from this point to the ending point, which is 20 kilometers. So that's going to be 20 squared. Okay, so let's expand that. 3 squared is 9 plus 2ab, 2 3s is 6x, just expanding the quadratic, plus x squared plus 100 equals 400. Okay, so we should rearrange this. We'll have x squared plus 6x, and this will become minus 291 equals 0. Now this one's a bit tricky. I suggest you use the quadratic formula here to solve this. The answer I got for x is going to be minus 3 plus or minus 10 root 3. You can check that yourself. Now the bottom number will be negative, so we don't want that. So the answer for x should be always positive because it's a length. So it'll be minus 3 plus 10 root 3, which ends up being 14.32 kilometers. Okay, so this length here is 3 kilometers, and this length here, x, is 14.32 kilometers. So the total length would be 17.32 kilometers along here. So that's actually the value you needed to find, x. In this question, we want to find the length of the side marked x in the following diagram. And as you can see, we have two triangles. They're both right angle triangles. We need to find this length x. But we can't find that length until we find this length here. Okay, so let's apply Pythagoras to this first triangle here. So this is the first triangle. That's the second triangle. So for triangle 1, from Pythagoras, we'll have 4 squared plus 4 squared, and let's call that length here, let's call that c, equals c squared. Okay, so 4 squared 16 plus 16 equals c squared. That's 32 equals c squared, and c is going to be the root 32 or 4 root 2. Okay, so if we want to find x, we know this value already, 4 root 2, and we know that's 2, we can find x. So this is triangle 1. This will be triangle 2. So in triangle 2, we'd have 2 squared plus this length, 4 root 2 squared, equals the hypotenuse, which is x squared. So this is 2 squared is 4 plus 4 squared is 16 times root 2 squared is 2 equals x squared. So we've got 32 plus 4, which is 36, equals x squared, and as you can see, x will be 6 cm.